Hello, today we're going to talk about ordinal regression. If you are new here, make sure to hit that subscribe button and turn on notification bell so you don't miss out on any updates. What is ordinal regression? Ordinal regression is a type of regression analysis used when the dependent variable has a natural order but the distance between levels are not assumed to be equal. It's commonly applied in fields like social science, medicine, and marketing. Assumptions of ordinal regression. 1. The dependent variable is ordinal. 2. The independent variables can be categorical or continuous. 3. The proportional odds assumption. So this implies that the relationship between each pair of outcome groups is the same. 4. No multi-collinearity among predictors. When to use ordinal regression? So we make use of ordinal regression when our dependent variable is ordinal and not continuous or nominal. 2. When we want to predict an ordinal outcome based on one or more predictors. Examples include rating scales, which can include poor, fair, good, and excellent, or levels of agreement, which also can include strongly disagreed to strongly agreed. For the purpose of this tutorial, we are going to be making these hypotheses to check whether agricultural policy has an impact on maize market prices. So for the first section, that is just under agricultural policies, we are going to be having, the first question will be, current agricultural policy effectively supports maize production in Ndola. Now, these are the following levels of agreement. So this is a Likert scale data, and respondents will respond based on their level of agreement. So we have the second question. So the first question is for agricultural policies. The second question, subsidies for maize production have a significant impact on prices. So the second is for subsidy. The third, implementation of fertilizer support program, FSP, improves the quality of maize available in the market. So this is for fertilizer support program. And the fourth one is the implementation of farmer input support program boosts productivity among farmers. So we're having 4 questions, and I am going to categorize these questions as 1. Policy, 2. Subsidy, 3. Fertilizer support program, and 4. Farmer input support program. So from these 4 questions, we want to see whether agricultural policies has an impact on market prices of maize. So quickly, we are going to be going to SPSS to work on this. So here we are in SPSS. So in SPSS, we are going to go to our variable view. So I have coded the necessary information here. So under questions for agricultural policy, we are having the following values. So 1 is for current policy, 2 is for subsidy, 3 is for fertilizer support program, and 4 is for farmer input program. So we want to see whether, using these 4 questions, whether we can check whether agricultural policy has a significant effect or impact on the market price of maize. So the response for our respondents is a Likert scale data. So they are to agree, 1 for strongly disagreed, 2 for disagree, 3 for neutral, 4 for agree, and 5 for strongly agree. So the respondents we choose based on their level of agreement. So after settling with the variable view, we go to the data view. So in the data view, we are going to input the various response to the various questions. So 1 represents the first question on current policy, and so on. So after done this, now we want to run an ordinal regression. So to quickly do this, we go to analyze, we go to regression. Under regression, we go to ordinal, and for our dependent variable, we put our response, and for our factors, we put questions. So we go to option to see whether everything there is checked. So we are using logits by default. So we go to our output, and we also add the test of parallel lines. So this assumption must be met if our data would be suitable for this kind of analysis. So we click continue. So having done this, we click OK. Alright, so this is our result. From the result, we see that the marginal percentage for strongly disagreed is 8.2%, and that of disagreed is 16.2%. Neutral is also 16.2%. Agreed 29.8%. Strongly agreed is 29.5%. All right, so for the current policy subsidy fertilizer support program, farmer input program, we have 100 participants responding to these questions. So let's go to the next model fitting information. So for the model fitting information here, we see that the chi-square with a significance level of 0.000 indicates that the final model with predictors significantly improves the fit compared to the intercepts. So the intercepts only here includes the intercepts only model. So whereas this other one here, the final here, includes the predictors as well. Okay, so and here we can see that it is significant. So for the goodness of it, okay, we're having the goodness of it here. So before we go to the goodness of it, we can also say here from the model fitting information that agricultural policies significantly contributes to explaining respondents' perception of maize market price. All right, so now let's go to the goodness of fit. Now, looking at the goodness of fit, for both the Pearson and the defiance, we can see that their p-value here is greater than 0.05 respectively. So this indicates that the model fits the data well, and there is no significant difference between the observed data and the predicted data. So let's go to the pseudo R-square. So the pseudo R-square, we have the various we have the coarse and the Snell. So this is a 0.686, and so basically this is telling us how well our model is explanatory. So the coarse and Snell here is 0.686. So this indicates that approximately 68.6% of the variation in the dependent variable is explained by the independent variable. Right, so now we go to the Nagelkaki. We are having the Nagelkaki here is an adjusted version of Coase and Snell. So this indicates that 72.1%. Alright, so for the Nagelkacke, Nagelkacke is an adjusted version of the Coase and Snell. So from our result, we're having 0.721. So this indicates that 72.1% of the variation in maize market price is explained by the model. So this value is closer to 1, making it a better measure of the model's explanatory power. So for the McFadden here, we are having 0.382. So this indicates that the model explains 38.2% of the variation in the log likelihood of the dependent variable. Okay, so now the values between 0.2 to 0.4 in this McFadden, okay, are considered good for ordinal regression models, suggesting this model has a decent fit. All right, so now let us go to the parameter estimate. So for the parameter estimate here, we can see that we're having thresholds as well as location here. So the threshold describes the cut points that separates the ordered response categories. So in this case, we can see from the p-value that all thresholds are statistically significant, meaning that the categories are valid and distinct. So now let's go to the location. For the location, each question here represents a specific type of agricultural policy. So we have the current policy, subsidy, and so on. So for question 1, we can see that the p-value here is significant, and this suggests a strong negative impact on market's price of maize. So you can see that the estimate is minus 4.392. Also for question 2, we said that the estimate is 3.817, and it is positive with a p-value that is less than 0.05. So this suggests a strong positive impact on market's price of maize. So for question 3 here, we see we're having minus 0.542 here with a p-value that is slightly less than 0.05. So there we can see that we have a negative and marginally significant p-value here, which indicates a slight negative impact on price. And category question 4 here is used as our reference category. That is why it's set as 0. All right, now let's go to the test of parallel lines. So the test of parallel lines checks the proportional odds assumption. Remember, when we're talking about the assumption for ordinal regression, we said that we also look at the proportional odd assumption. So this talk about whether the relationship between the predictors and the odds of the outcome is consistent across response categories. So here we're having a p-value of 0.121, which is greater than 0.05. Hence, we can conclude that the proportional odds assumption is met and the model is valid for interpretation. So these are the results we got from our ordinal regression. So based on this result, we can give a final conclusion for the hypothesis we stated earlier that agricultural policy has an impact on the market price of maize. So now from the model, we can see that different agricultural policies significantly influence market price of maize, as evidenced by the significance of the parameter estimates for all questions except the reference category. Also, we notice that current policy has a negative effect, why subsidy has a positive effect on prices. The fertilizer support program has a minor negative effect. So in conclusion, we can say that our results support the hypothesis that agricultural policy significantly impacts maize market prices. So this is where we are going to be ending the tutorial for today. If you have any question, feel free to drop your comments in the comments section, and also do not forget to subscribe to my channel. Hit the notification bell to get instant notification once new video is dropped. And if you find this video helpful, give a thumbs up, like, and share.